Good morning, students. We'll continue that previous class. In that previous class, we were discussing about the lens maker's formula. Okay. Then there I was saying you about the refraction at surface ADC. I mean at second surface. There in that we got image in rarer and object was in denser medium. For that there is one formula that here I have written by considering the sign conventions. Previously, when we were discussing about refraction at ABC, there also we written one formula, I mean equation 1. That equation 1 is also with sign conventions. With sign conventions means what? That object distance, image distance, radius of curvature, are they positive or negative? Like that we have to think. But what formula I have written, that is including sign convention. No need to apply sign conventions again. Have you understood? Just you go with that direct formula, because already we derived that formula by considering the sign conventions. Here also I have written this equation 2 by considering the sign conventions. See here, n1 by v. Here n1 by v. I mean v is the image distance, minus n2 by v1. v1 we treated as a object distance is equal to n1 minus n2 by r2. n1 minus n2 by r2. In equation number 1, their denominator and numerator, when you look on that equation, in the numerator there you written n2 minus n1 by r1. I mean in equation 1 at RHS side you have written n2 minus n1 by r1. To take this also in that way, what I have written here? This one only I have written like this. What I have done here, I have taken minus as a common out here. Getting here what I mean to say? See here, what I have done? This is nothing but same only. Minus of n2 minus into plus n2 minus n. Here it is there. Minus into minus plus n1. I mean it is like again n1 minus n2 only. This n1 minus n2 I have written like this. Both are same. Have you understood? Again in denominator I have written r2. This is very important. I mean this is equation number 2. Have you understood? This is the expression when you getting image in rarer medium and when you kept that object in denser medium. Yes. So I mean we got two equations. Equation 1 for first surface, equation 2 for second surface. Now you add these two equations. Add these two. There in equation 1 in LHS side there is a n2, see here, look here, n2 by v1 minus n1 by u. This is the LHS side of equation 1. LHS side. What I have written here, add both equation 1 and 2. Add their LHS and add their RHS sides. So this is the LHS side of equation 1. Okay. Plus this is the LHS of equation 2. That is here n1 by n1 by minus n2 by v1. Similarly, you add their RHS sides. There in that equation 1, in the numerator there is a n2 minus n1. Here in equation 2, in the numerator there is n2 minus n1. So we going to take that n2 minus n1 as a common in the numerator. We understood? That's why I have written like this. n2 minus n1 I have taken common in the numerator. Then into what left, which thing is left in equation 1? That is actually n2 minus n1 by r1 is there. Then which thing left there? 1 by r1. That I have written. 1 by r1. According to this, here there is a sign convention. I mean negative. Here there is a negative. Minus which thing is left here? 1 by r2. Have you understood? Yes, N2 minus N1 into 1 by R1 minus 1 by R2 is the RHS side of both equation after adding. Okay. Now go with simplification. See here. Here this N2 by V1 is positive. And what about this N2 by V1? It is negative. I mean these two are going to get cancelled out. N2 by V1 minus N2 by V1. They are going to get cancelled. Then which thing you left? N1 by V minus N1 by U. Here this side, I mean at LHS side, two terms you have. In both those two terms, in the numerator, which is common, N1 is common. So take that N1 as a common in the numerator. Then N1 into 1 by V minus 1 by U. Have you understood what I have written here? I have taken N1 as a common, and here 1 by V is there, here minus 1 by U is there. This is LHS side. Then equal to, same thing I have written as usual, N2 minus N1, and same thing, into 1 by R1 minus 1 by R2. Now you look here, what I am going to do? This N1, I am going to send towards this RHS side. Here it is in a numerator. When you will send this that side, then it will come in denominator. This N1 will come this side in denominator. That's why I have taken. I have taken this N1 here below to this one. N2 minus N1 divided by this N1 and this equation as usual. Getting what I meant? Now look here. Here I have written this again like this. I splitted this. This N1 is being a denominator for both. I splitted that. I have written as N2 by N1 minus N1 by N1 means 1. N2 by N1 that I have written here minus N1 by N1 is 1. I have written N2 by N1 minus 1 into 1 by R1 minus 1 by R2. Now come here. LHS. I have written same. 1 by V minus 1 by U is equal to this N2 by N1. Even we can write as a N21. Already in a previous class, already we discussed. Okay, N21. Even we can write as a N2 by N1. We can write as a N21. Refractive index of second medium with respect to first medium. Then minus as usual, and this one as usual I have written. I named this as a equation number 3. Okay, this is equation number 3. Look on this. Now here V is the final image distance, U is the object distance. Okay, R1 is the radius of curvature of first surface, R2 is the radius of curvature of second surface, and N21 is the refractive index of second medium. I mean that lens medium with respect to air medium. Okay. Now see here. Some imagination we are going to consider here. If you think like that, if you would have imagined that object is at infinity, you right now in this expression you kept it at u distance. You now imagine like that, you imagine that object is at infinity. Then object distance u is nothing but equal to how much? Infinity. In previous class we discussed, when object is placed at infinite distance or at infinity in front of biconvex lens, then it is going to produce the image at a principal focus point. Then it is going to produce image at a principal focus point. This is biconvex lens. Object is at infinity. Then image is at a principal focus point. Then this is now image distance. Then how much it is? That image distance I am going to take as a small f. Why? Now image is produced at principal focus. I mean you have to measure that distance from optical center to that principal focus. That distance already be called as a focal length. Are you getting what I mean to say? This is lens. Here it is optic center, from here to principal focus point. This distance we call as a focal length. That's why here we have to treat image distance V is nothing but equal to focal length small f, that I have written here. When you treat it like, object at infinity, then u is equal to infinity, then image is going to produce at principal focus, then that image distance is going to be equal to focal length, that is v is equal to f. Okay, then you take these u and v values and substitute those values in equation number 3. Take these two and substitute in equation number 3. See here, 1 by v, v means what? F. That is 1 by f, minus 1 by u is what? Infinity. 1 by infinity, 0. That's why I left that. I have taken only 1 by f. That is equal to, this is remains same. 1 by f is equal to n to 1 minus 1 into 1 by r1 minus 1 by r2. This is our final expression, which we call as a lens maker's formula. Here, this is an expression for lens maker's formula. It is an equation which is going to relate the focal length, refractive indexes and radius of curvature of that lens. Have you understood what it means? Lens formula or lens maker's formula is an expression which is going to relate the focal length, refractive index and radius of curvature of that respective lens. Have you understood? Yes. Now, one more thing is that, see now, I have written, you just compare this equation number 4 with 3. Just you compare these two. What you can imagine here? Look on these 3 and 4th equation. Their RHS sides are same. Their RHS sides are same. Then obviously you have to take their LHS sides are also same. RHS sides are same, then LHS sides are same. Then what you can consider here? You can consider this 1 by f is equal to 1 by v minus 1 by u. That I have written here. 1 by f is equal to 1 by v minus 1 by u. There v is the image distance, u is the object distance and f, small f is the focal length. This I have treated as, or we have to call as a thin lens formula. Thin lens formula. For thin lens we are going to consider their focal length. Okay, like this type expression, 1 by f is equal to 1 by v minus 1 by u. This is a very important derivation. Here in exam already I said you will be getting question like that. Derive an expression for lens maker's formula. Just there you have to take those 3 respective diagrams. Firstly you have to draw that single lens diagram. Okay. Thereafter you take that separately, refraction through that first surface ABC. There you have to imagine that second surface is absent. That's why there you getting the image in denser medium by keeping object in rarer medium. For that case, there is one formula that you have to use and name it as equation number 1. Then go for second, refraction through that second surface ADC. At that time, you imagine that the first surface is absent. Then their question arises, then this incident light ray, from where it is coming? Okay, to answer that, you imagine, you further extend that incident light ray in that lens. It going to meet at I1 point. That I1 you have to treat as a virtual object for this second surface ADC. You think that I1 is somewhere here in this denser medium and behaving as a virtual object. That's why in this second case you take this V1 distance as a object distance. Then thereafter that light ray getting refracting and bending towards the principal axis, and there it going to produce the final image I. Their distance you have to take as V. That V is the image distance and V1 is the object distance. And here you imagine object was in denser medium. Image you got in rarer medium. For this case, there is a general formula with sign convention. Go with that formula and name it as equation number 2. Okay, equation 1 was for first surface, equation 2 was for second surface. After getting those two equations, just you add them and thereafter you go with some simplification step. And finally you will be getting 1 by f is equal to n to 1 minus 1 into 1 by r1 minus 1 by r2. This expression is called as lens maker's formula. Have you understood? Yes, it's a very important expression. You go with that and just practice, you will be getting some perfection over there. Okay? Yes. After this, now we go with the linear magnification of a lens. Linear magnification. Already I said linear magnification means it is the ratio of height of the image to the height of the object. I have written here that linear magnification we are going to represent with a small m symbol. M equal to height of the image to the height of the object, that is equal to h dash by h. H dash is the height of image and h is the height of the object. See here I have written two formulas. It's very important concept. You will be using these formulas while solving the numericals. You keep in your mind when we have to take it as a positive and when we have to take it as a negative. Very important. Title is linear magnification of a lens. There are two kind of lenses, convex lens and concave lens. This concave lens is always producing virtual erect diminished image. Okay, that we discussed. But this convex lens is producing both real and virtual objects. Now question arises, here I have written for virtual erect image produced by concave or convex lens, then linear magnification becomes positive. For virtual image by concave and convex lens, linear magnification becomes positive. M equal to h dash by h is equal to, I have taken as a v by u. This directly has given in your textbook. According to our syllabus, there is no derivation. How we got? See here for these two, just briefly I will tell you. Just go with that in practice for you. Virtual image there. Take a biconvex lens. To get virtual image, we have to keep that linear object AB between its optical center and principal focus. Place it like this and take two light rays, one parallel, allow it to pass through the principal focus point and one more through the optical center. These two refracted light rays were looking diverging. I mean they are not going to meet somewhere. So you have to extend them backward. Here lens there, here object there, AB. Here you will be getting A dash B dash. Virtual, erect, magnified image you will be getting here. Lens, AB, see here optical center. Getting what I mean to say? Here A dash B dash, optical center. I mean here you will be getting two right angle triangles. A, B, O, A dash, B dash, O. These two triangles are looking similar triangles. If they are similar, then the ratio of their adjacent sides are equal. Then AB by A dash, B dash is equal to AO by AB by A dash B dash is equal to BO by B dash O. This base B to O, to that B dash to O. Getting what I mean to say? AB is H by BO is which distance? U. I mean like this, if you go with this imagination, with this geometry, there you will be getting, then M is equal to H dash by H is equal to V by U. Have you understood? To know that how it is V by U, go with those two similar triangles and apply the condition. There you will be getting H dash by H is equal to V by U will get by applying sign conventions there. Then you treat, then that linear magnification M is equal to H dash by H is equal to V by U. For which image? For virtual erect image. That only I have written here. This formula is directly given. So just for your information, you just go with that imagination. Have you understood? Yes. Not only by convex lens, even by taking concave lens also, you will be getting virtual image. If you apply, there also will be getting two similar triangles. Then apply the conditions. Again there also you will be getting M equal to H dash by H is equal to V by U. You have to remember linear magnification for lens for virtual image is equal to V by U. Okay, you will be getting some numericals to solve with the help of this formula. There you have to keep for virtual image it is positive, and for real image, for real inverted image it is negative. When we talk about a real means that concave lens is not producing real, that convex is only producing real inverted image. Again you take a biconvex lens and keep object beyond principal focus, anywhere you will be getting there real inverted image. Getting what I mean to say? Here object vertically head like this, AB, this is optical center, ABO, this is one right angle triangle. Getting what I mean to say? Here you got inverted image, AB, okay, AB or top one as AB, anything according to your representation, you go with that. AB, here O, AB, O. Here you will be getting A here means there A dash will be here, A dash, B dash, O, A dash, B dash, O. Again these two right angle triangles looking like similar. Again by applying that condition, here we will be getting that m is equal to, okay, h dash by h, there we will be getting negative, that ratio only, but here we will be getting it as a negative, that is equal to minus v by u. Okay, v by u only, but it is negative for real image and positive for virtual image. That you have to keep in your mind. Okay, it's very easy. I mean, what magnification is nothing but a ratio of height of image to the height of object, that we are going to treat in terms of ratio of image distance to the object distance. For virtual it is being positive, and for real image it is being negative. That's it. Okay, this is about magnification of lens. Then after this, see, now look on this one, power of a lens. Power of a lens, that we are going to represent with capital P symbol. Here you look on this diagram. Okay, here I have taken one biconvex lens. This is optical center, and this dotted line is principal axis. Okay, here a parallel light ray is coming. A parallel light is coming which is at distance h from the principal axis. See here, this one, this distance. Getting what I mean? This is at a distance h from the principal axis, and it going to incident on that biconvex lens, and it going to converge. Here it is converging lens, that's why that light ray was converging. If here it is concave lens, then that light ray is going to diverge. This, the ability of converging or diverging the incident beam of light is called power of a lens. They may ask question, define power of a lens. The ability of the lens to converge or to diverge the incident light ray is called power of a lens. This is one definition. In simple way, it's their ability to converge or to diverge that incident ray of light or beam of light. Have you understood? Yes. This is one definition. How much it will converge or how much it will diverge. One more definition is that, see, the power of a lens is equal to the, it is tangent of the angle by which it converges or diverges the incident light beam which is passing through the lens at unit distance from the principal axis. What it means? Before going with that definition, just look on this diagram. Try to understand the diagram first. See here, biconvex lens there, principal axis there. Here one light ray is coming. This is a light. It is coming. This light is parallel with respect to principal axis, and it is at how much distance? It is at h distance. That we define it. With respect to principal axis, it is at unit distance, 1 unit. It is at unit distance. A light ray just above or below that principal axis at unit distance is coming and going to hit on that lens. Thereafter that it is bending inward if it is convex lens. It is bending outward if it is concave lens. Now you see that light ray gone like this. It got converged. Instead of going straight, it bent in this way. Here delta is represented. What is this delta? Delta is the angle of deviation or angle of convergence. This light ray, how much it converged? This much it converged. Converging means what? Bending.